Frank Lamb with Automation Consulting, and this is a webinar from August 14th, 2020. Well, boys and girls, it looks like no one is here today, so I'm just going to play by myself. What I've done here is created an OB1. OB1 is the main routine, and I've created a little always off and always on bit here using some of Siemens styles. Here I've got a scan counter. This is counting scans constantly. And you can see here that what happens is we load one into a register, we load a memory word, we add the two together and move it back into the memory word, and that constantly updates the accumulator. Then I have some network calls here doing various different things. We have an artificial control system here, FC1. What this does is sets auto and manual mode using push buttons. Then we do a cycle start. As in my book, we use a timer, 3-second timer. So when the push button is on, the timer times. You can see we're already in auto cycle here. What this does is prevents the cycle start request from being on when you're pushing the button if you're not already in auto cycle. So this is kind of important because we use this to sound the horn if we wanted to give a warning to people that the system's starting up. So this prevents the horn from sounding when the system's already in auto cycle. Cycle stop request. You can see here, if we don't have a permissive for the cycle stop request, then it just sits there and waits. I'm going to toggle that and push the button. You can see here we are in auto cycle. I toggle the button. We have a request for cycle stop, but we're not allowed to stop the cycle yet until the permissive appears here. So the permissive would be something like some system is running, operating in auto mode, auto cycle, and we don't want it to go out of auto cycle until that process is finished. That would allow you to go into manual mode and things like that. So what I'll do here is toggle the cycle stop permissive. And you can see we're now out of auto cycle. We're still in auto mode, just not in auto cycle. That's pretty much it for the control system itself. Other things I've done here is I created some physical outputs. The stack light, you can see here we're not in auto cycle, so the stack light would be blinking. The idea behind the stack light is this is the trainer that I'm using here. It has a stack light on it. This is the Siemens trainer that I'm using. You can see it's in run mode down here. I've got it connected via Ethernet. It's similar to this trainer, which was the trainer that I used last week for the Alan Bradley seminar. So you can see the stack light down here. which is already lit. If I do a cycle stop, here you can see it blinking. So that is similar to what would be going down here, but I haven't wired this all up yet. So cycle start. And you're blinking. And that's the same kind of thing that we have here. So once again, stack light is yellow if we're in manual mode, and it's red if we have a fault. So that's all I'm really doing with the physical outputs here. Notice that I've assigned them to Q12, which is the first card that I have in the outputs. Let's take a quick look at the hardware, see what we've got here. This is the hardware setup that I've got currently. Got some input cards here, words 0 and 1. Those would be I0 and I1 bytes. These are I4 and I5 bytes. These are the defaults that are assigned based on the slot position. So slot 4 is always assigned to byte 0 through byte 3. Slot 5 is always assigned to byte 4 through byte 7, and so on. Slot, let's see, 6 is an output card, slot 7 is an output card, and then slot 8 is an analog card. So that's kind of how we've set up the hardware. A few other hardware features. I did enable the clock byte. I made that memory byte 1, and memory byte 1 is ticking along. We'll take a look at what it looks like here. We have already compiled this and downloaded it. So we'll look at our blocks, and here's the clock byte. If I monitor this, you can see all of the different bits ticking at different frequencies. I use these for different things. This 1 second bit here is used for accumulating our time. You can see it appears as if it's counting. It's not actually counting evenly. It is, this is pulsing every 100 milliseconds, 200. It would double every time if it were counting evenly. So it would go 400, 800, 1600. But instead, there's extra bits in here. So that's how the clock byte works. And back down here in OB1, I wrote a little function block here that accumulates time. It counts minutes, seconds, etc. And I did a test of it first by moving it into these fixed locations, these memory words. You can see 40 through 44. And then, of course, I monitor those here. And you can see that I started this 46 minutes ago. 57, 58, 59. Right? When it hits 60, it resets the minutes. And when the minutes hit 60, they will reset the hours. Let's take a quick look at the code in function block 1. Now, I used all local variables here, as you should in functions and function blocks if you are making them reusable. So my input parameters are the clock, that is that 1 second pulse that I had created before. The device is the thing that's being measured, so we pass that in. If the device is on, the clock is ticking along, and we add 1 to a register and move it back into that register. And of course, we had to use a one-shot here. Now, just during my testing, I actually created a one-shot in the temporary register first. And I tried that here, and what happened was it ticked at full speed. So it would actually get 60 ticks of the seconds within probably 600 milliseconds. So it was counting up very rapidly. And the reason was that this has to be a retentive value. This needed to be in the stat, which is why I created another one shot to kind of illustrate this. One shot number 2. So one shot number 1 is not used, and that's okay. You can just leave it there. And then the outputs, I pass out the hours, the minutes, the seconds, and the done. So we pass in a set point, and when the value is higher than whatever the set point is in hours, then we say that we're done. And then somebody would reset it or whatever. So really what these are counters, but Siemens counters don't work very well. One problem with Siemens counters is that they are done when they are not 0. So you really need to move a set point in, say 60, and then count down to from whatever your set point is to 0, and then you would be not done. So you could use the normally closed of the done bit. That's the way that works. So we're just counting here, adding seconds. When the seconds are at 60, we add 1 to the minutes and reset the seconds. So that's just like a counter, except I'm not using Siemens counters. Once again, when the minutes hit 60, we count the hours. We move 0 into the minutes. When the hours are greater than whatever you have as your set point, then you are done. Done bit comes on, which is an output parameter. So it comes on as a bit. The reset moves zeros into all 3 of the seconds, minutes, and hours. And then here, notice that I use statement list, STL. And the reason is if I had used this by using move statements like this, right? Here are 3 move statements with a reset. It would have looked something like this. So there would have been a whole lot of JNBs. And the only thing we really needed was the load and transfers, right? Load 0 into minutes, transfer into minutes, and so on. And that's why I did this. So I actually did it in ladder first, converted it to statement list, and then there was a whole lot of extra stuff. And so I just deleted the extra stuff. And this just constantly moves this stat variable into the output variable. The reason we had to do this, you can't do any math or add or anything to stat variables. So for instance, if I had tried to pass this out, I couldn't add the hours to the hours. It wouldn't let me do that to an output variable. You can't add it. at least not in ladder. Sometimes you can do that in statement list, but you can't do it in ladder. So I'm just guessing here, but there is no one else on this call. I'm the only participant, which is why I'm talking to myself. I'm just recording all of this. No one showed up today. I'm the only one, but I'm recording it anyway. So we'll see how that works out. Got about 25 minutes left. Don't know if anybody else is going to show up. If they do, we're ready to go. So that's a bit about the function block that's doing the time accumulation. This is a reusable function block, which means that everything in here are these local variables. I did not use any memory words or data blocks inside of here. Everything has to be local up here in these parameters. Very important to make it reusable. Now, what I mean by reusable is if I go to OB1, you can see that I call FB1 with one data block here, and I pass these variables out, and I'm using different variables in. I'm using a couple push buttons. And then down here, I call the same FB1 again, but I use a different data block. These are called instance data blocks. They get created automatically. And if I monitor these, you can see I've got different times in here than I do in here. So we got 54 minutes, 21 seconds here. You've got 18 minutes and 4, 5, 6 seconds here. So we're using different internal data blocks. Here I use memory words just as a test, right? Made test hours, minutes, and seconds. And here I used a UDT. So I made something called auto time, and then I used the UDT to put the values in it. Now you notice here, my set point, my hour set point is at 0 here, and that's why my done time is in here. So I'm going to change that. I'm going to go into my junk DB here, and we'll just put in this hour set point, which is db4.dbw6. So if I make this decimal, we can then put any kind of set point we want in here. I made that part of the UDT. Make that a little wider. And we'll put, say, 10 in here. And we'll let it run for a while. So now we're at 10 hours, and our done bit should be off, as it is, right? Because we got 10 hours in here. So unless it's greater than 10 hours, the done bit won't be on there. So these webinars, these Zoom webinars here, are set up so that I can practice. That's the main reason. And I plan on teaching these classes live, and I want to see what they look like. So I'm recording them and seeing what they turn out like. I can go back and look at my own work. Since we're using Zoom here, I assume everybody can see all this up here since I'm sharing this screen. Right. And then I've taken this little thing here and moved it in place. So I'm going to go look at what this looks like a little bit later. can see the 1 second pulse ticking along there. That is from that clock byte that I used before. So the idea of using this reusable code is I could call FB1 for auto mode and auto cycle and idle and blocked and starved and all kinds of different things to describe the status of the machine and do data acquisition this way. And I've got all these nice little structures. I could have put all the structures in one data block. So I'm going to do that real quick here. I'm just going to see how that editing works out. I'm going to create a data block here called machine status. So we'll make this locked. I'm not a very fast typist. So a lot of times I like to copy things. So now I can save this. We'll download it. It's made up of this UDT runtime. So now when I go look at this, I can see machine status blocked hours, machine status blocked minutes, etc. I can use this to accumulate all my time. So that was created pretty quickly because I'd created the UDT only once. That's the general idea behind it. So once again, make sure it's saved, downloaded. There's nothing wrong with downloading more than once. So here I have my little test FB with DB40. Here I have my time accumulation for auto mode, right? And the next thing I'm going to do is copy this, paste it. We're still going to use this same little ticking time point, but this time we're going to use machine status. Actually, we're not. We're going to use system. And we're going to do our starved first, I believe. Then we're going to use our machine status. So this is the set point. Let me see if this is right. No, Still not right. Oh, actually it is. So we're going to use starved dot set point. Starved dot reset. Starved dot hours. Minutes. Seconds. And done. So now I've got all my output variables here, and we're going to use a new data block. We'll use DB42. And it says it doesn't exist yet. Do you want to create it? Yes, I do. We don't have a name for it yet. So this is where we have so we're going to call it starved DB. So very important, we want to download this data block first. And then we can download, actually, yeah, I think we've downloaded the other data block. Now we can download OB1. And we're running okay. We don't have any red lights, that sort of thing. It's very important. Go ahead and see if we're, whoop, accidentally hit download instead of my glasses. That's okay. So we're going to toggle our starved device here. There we go. You can see we're one. It's kind of not obvious where some of these things are. And you can see we are accumulating our time. And our time just sits there at 29. So with the clock ticking away. So if I go offline, paste this a couple times, it's actually pretty easy to just change these to whatever we need them to be. Say DB43 doesn't exist. I want to generate it. DB44 doesn't exist. We want to generate it. DB45 doesn't exist, and we want to generate it. So I've created all the things I need, and I just need to edit all of these. So this one will be blocked. If you make a mistake, sometimes just hitting the escape key fixes all of that. So this will be blocked set point. If you're a really fast typist, then you can just type this in, but I'm better with the mouse than I am with the keys. So this is pretty quick compared to typing everything in all the time. So before we download this, it's going to be very important to download all the data blocks first. But I'm going to show you right after this what happens if you accidentally download OB1 before you download the blocks. So we'll make this, I don't remember if this is idle, what we did here. But I think we can just pick anything. I don't think it really matters which block is which. We just need to remember which is which. So what this represents is the state of the machine. Idle means it's not being fed any parts, but it's not starved, which means it's not that it's not getting parts from upstream, and it's not blocked, which means it's not being prevented from passing products downstream. It's just idle. Maybe the operator has put it into a stop mode or something like that. So that's the general idea behind accumulating all these different times. And the only thing left is, I believe, faulted. All right, so we've done starved, blocked, idle, and faulted. And we'll want to go name these data blocks when we're done with that. So that should take care of all these. Sometimes it's a good idea to write things down. So I'm going to do that just so I can remember things. We have starved, blocked, idle, starved, blocked, idle, and faulted. And these are the things that we need to name the data blocks. So when I go to my manager, which is the source of all things, we'll go ahead and, okay, that's already been named. It's not showing up here. That's okay. These names aren't super critical here, but where they do show up, right, and I'm going to purposely kind of forget some things here. Where they do show up is here. So that kind of shows you what this block is, and it allows you to match the data block to all these tags. So now I'm going to show you what happens if I do a download here. It's going to cause a problem if I download OB1. So I'm going to go ahead and do it. While I'm doing it, we're going to look down here at the processor and see what happens. So I'm going to hit download. Says it already exists. Yes. And what happened? We got a red fault light. And the reason we got the fault light is because I'm using all of these data blocks, but they don't exist in the processor yet, right? So here's a way to check that. Okay, so here's how you check that out. If I go here and I look at processor, you can see 41, 42 are in there, but the other ones aren't. So I'm going to download 45, 44. I'm going to download all 4 of these. And you can say all here. Now they're all in the processor. If I'm not sure, I can always go here and look. So how do I fix the problem with the processor, which is this fault? Well, of course I can reset this with this button. That will fix it. But the other thing I can do here is I can download OB121 and 122. They take care of faults like that. So we're going to create those real quick, download them. And they will stop us from going into stop mode every time we fault when we have a programming error. So common programming error would be forgetting to download things. That is the job of OB121 and 122. So you download these. and they prevent the processor from stopping. Well, that is the end of, oh, someone showed up. Hello, Lloyd. Are you there? Can you hear me? So I can't see you or hear you, but it looks like you're here. So this is a little group chat. You can see this here. Unfortunately, Lloyd, the I don't know if you can hear me. Hopefully you can. But I've already done the webinar. It started an hour ago and nobody showed up, but I did record it. So I'm going to be putting it on probably the YouTube channel. Basically what I did here was create a lot of this stuff here. I may be able to kind of hear you. Can I hear you? Are you there?
Hello.
Ah, hello.
How are you?
Oh, okay. How are you?
Good. No problem.
Yeah, so I started the webinar at 10 o'clock my time. It's now a little after 11, so it's already kind of over.
I'm late because I'm using South African time, so I wasn't sure exactly which time will you be on. So,
well, I'll tell you what. You know, since you're here, my wife's going to be coming, and we're going to lunch eventually here. But I'll go ahead and show you through a little bit of what I did here. Okay.
All right.
Okay. So this project I started yesterday. Let me see if I can see your camera, but I don't think you can see, let's see here, my camera.
I can actually see you, but all right, yes.
Can you see a PLC down here?
Yes, I can see. It's a Siemens PLC. Yeah.
Okay, good. Yeah, so this is the trainer that I'm using.
Okay.
And I just built this yesterday. So I just put power to it, and but I haven't wired anything up to it yet. So you can see there's no wires on the back.
Yeah,
So
I see. Yes.
everything that I did here was kind of virtual. This is another PLC that I used last week. So this is an Allen Bradley, and I did a little seminar last week, just like this here. And it's the same, right? It has the same buttons and switches and things like that on it.
Yes.
But anyway, so that's the way that works. So I can't see me, but anyway, there we go. So that's me.
All right.
So show you a little bit of what I did here. So of course, first I created a processor and downloaded it yesterday, and then created various different things in the OBs. So the first thing I created here, this is a typical way to do an always off and always on bit. People use these for system bits, right? Just always on, always off. If I look at it here, right, this little not bit, this is a cute way of doing it. You know, Allen Bradley, you do it a little bit differently. I can actually, with Allen Bradley, I can connect directly to the rail with no instructions. That's legal. But with Siemens, of course, you have to use a bit of some kind in series. So this is a cute way to do it. I assume you'd use a little bit of statement list, STL, right?
Okay.
So what this does, this is simply an adder. So what this does, it takes one, it puts it into the accumulator, and then memory word 102, which is just an arbitrary memory word. I add it to it and I transfer it back into itself. So it's just an add, kind of like this is, right? one
Okay.
plus this into this. It's the same thing, but it's in statement list. So the end result of that is every scan, this is adding. So if I wanted to look at my variable table and see what it's doing, I have this little junk routine here, and this does cyclic scans. So it's adding is every scan, it's adding one to it. It's just going as fast as it can.
All right.
Okay, so I just did that to kind of illustrate how scans work. And I use these memory words just arbitrarily. I just picked them, and it doesn't really matter. That's what the M area really is. So first scans, what this is inside of OB100. I don't know if you knew what all the extra OBs do. Are you familiar with those?
The operational block is
100 is a first scan OB, right? This runs. What's that?
Are we talking about something like in the Allen Bradley RX 500, the one-shot falling or one-shot scans? Are we talking about something?
No. If you were doing Allen Bradley, there is a bit in the Micrologics, for instance, called first scan. It's actually S:1/15. Here, instead of using a bit, which there is a bit, but here they actually use a whole routine. So this routine runs one time every time you restart the processor.
Yes.
So all OBs have special purposes. OB100 special purpose is it runs one time on first scan.
All right.
So the end result is if I stop the processor. So I'm going to stop the processor here, right?
All right.
So I stop it. It's not in run mode. And when I restart it, this 6 up here is going to go to a 7. Did you see it?
Okay. All right. Yeah. The first scan. Yeah.
Yep. So if I do it again, it goes again, right?
Okay.
It's
Okay.
counting
All right.
first scans. Yep.
All right. Okay.
So OBs all are blocks with special purposes. That's this one's job, right? It runs first time. Now this periodic scans, what I did here, it's another OB, and it's a hardware OB. You actually set it up in the hardware. So I'm going to show you that here. There's OB35. If I open it up, it has another little adder inside of it. It's doing the same thing. But the way you set that up is you go into your hardware. So this is the hardware configuration. This is where you set up all your inputs, outputs, etc. Right? That's this. So that's where I got my addresses, 0 and 1, 4 and 5, 8 and 9, right? Q8.0, Q9.0, that's what all these are. But if I go here, I double click the processor, there's a couple things here that are good to know. This is the clock memory. This is where I assigned a clock byte. I just put a 1 in there. And this is cyclic interrupts. So you see the 35?
OB35, yes.
Yeah, so what that is that's an interrupt that runs every half second. It runs whatever time you want to put in here.
Okay.
Right, so if I put 800 in here, then every 800 milliseconds that will run, right? It's in milliseconds. So I can say, okay. Now, every time you change hardware, you have to save and compile.
Yes.
And then I download, right? And it is going to stop the module. So this is a really important thing. You don't want to stop your machine if it's running, right? And other people care whether you've stopped it or not. So I'm going to say, okay. And it says download, test functions are active, loading cannot, close all test functions. So what that is here is you want to make sure you're not monitoring anything.
Or you can adjust.
Yeah, if you're monitoring, you'll actually wreck your processor. So that even means here, right? So I want to not monitor. You want to be offline. It's not really offline. You're still connected, right? But you want to make sure that nothing is green. Okay, so now go back.
So basically during that moment, is your PC on? Is your PLC on by that time? Is it your process running, or it has to be off?
It is running. It is running, right? So let's try another download, and you can look at it as I download it. So you can see the green light there means it's running. If I do a download now, let's see if it runs. Okay. Okay. Here we go. It says will be stopped for loading of the system data. So it stops, right? It's yellow now, and then it says, do you want a complete restart? Yes. So it blinks a little bit, and now it's back running again.
Okay. All right.
So anytime you change hardware, you have to do that.
Okay.
So these other changes, right? If I change something, some minor thing in the code, I can download and it does not stop the processor. That's a difference between Allen Bradley and Siemens. When I do a download, I don't stop anything in Siemens.
Okay. All right.
So we'll quickly take a look here, and I'll do some kind of a download. We'll talk about that one later. We'll monitor this. Okay, so I'm looking at OB1 here, right? It's calling these routines. That's what these are, subroutine calls. I can monitor it, right? Now I'm back with my glasses. That's what you do, turn the glasses on and you can see everything.
Okay.
Okay, and I'm gonna make a code change here. Okay, and that'll kind of show you that I'm not gonna stop the processor to do that. So to do that, you turn this off. I put a rung in here, and I already have some kind of pre-prepared bits. So I'm going to call this HPB4. This is in the symbol table.
Okay.
And HIND4, which are, these are fake, they're just fake indicators and bits that I put in here.
Okay.
So there's a change, right?
Please.
Okay, so I save it and I download it, and it will not stop the processor.
Oh, okay.
Okay, so the processor's still running, nothing's changed. I'm back to monitoring, and you can see that, indeed, it is running. Right, I turn on HPB4 and HIND4 is on.
Okay, all right.
So that's the general idea behind that. You can make any change you want to. Now, OB1, its job is the same as main routine or ladder 2 in Allen Bradley.
Allen Bradley. Okay.
Yeah, it runs all the time. It calls all the other routines. So all these other ones, FCs, all an FC is a subroutine.
Okay.
So I'm going to monitor this subroutine. This is the same thing I did last week. I don't think you were on last week's call.
No, I was on, yeah.
Oh, you were? Okay.
No, I wasn't. I wasn't on.
Oh, you weren't on. Okay. So what this is, I made a system routine here. And what this is in auto and manual mode, right? And I even used a little, let's see what this is. Turn that off. So Siemens, are you familiar with Siemens? Do you use it a lot, or?
No. I just started RS Logic 500. So on Siemens, I'm just completely a beginner. Okay. So even some of the things that you're doing,
yeah, but it's ladder like any other ladder, right? But the difference is here, like instead of using B3s and things like that, you can create in Siemens. This is what makes Siemens a lot more powerful than the Logix 500. Siemens allows you to create things like this. Okay, here's a data block. So what I did here is I just typed things in, right? I'll create a new data block, right? So data blocks are just collections of data. So insert new object, data block. Okay, I can make a name for it, and I'll just call it stuff, right? I don't have a good name for it, so I just call it stuff. All right, so it doesn't have anything in it. So you can put things in it, right? Right now it has this little test integer, but I'm going to call it word1. Okay, since it's an integer, it's a word, and you can name it, comment it, anything you want to. comment 1. Okay, I hit enter. You can also create an array, for instance, which of course in RSLogix 500, you can't create an array. But this is a handy thing to be able to do. So for instance, I want one-shots. I go ahead and create an array, right, of one-shots. And I can number them, we'll say from 1 to 32. And you have to type it in this way. So Siemens is picky about how you type things.
How you type, okay.
Yeah. So I can make an array of anything. It could be an array of words, but I'm going to make it an array of bools, which are bits.
Yeah, bits, yes.
Okay. So once I do that, you notice this jumped here to 6. So it's saying you've got 6 bytes worth of data in here. Word 1 is 2 bytes. And then all these one-shots. I made 32 one-shots. That's 32 bits. Here's another way to look at it. It's a data view, right?
Okay.
So now I have one-shots 1, 2, 3, all the way down through 32. If you were doing this with Allen Bradley, you can create arrays in ControlLogix also, but you must start at 0. So one of the things I like about Siemens that is not as good in Allen Bradley is I can number things from 1, right? Allen Bradley would have been 0 through 31.
Not just to be 0 going is.
That's right.
15,
so,
yeah.
Yeah. So if I had like recipes and I wanted to have a, you know, hey, the operator is going to choose recipe 1, recipe 2, recipe 3.
Oh, okay.
I'm wasting recipe 0, right?
Oh,
because
okay, yeah.
the operator doesn't like 0.
Yeah, because the 0 is not existent. It's only here on PLC that is being recognized. So now he wants to start at 1. That's a more familiar way, yeah.
That's right. So I could have made recipe 1, recipe 2, recipe 3 that way. But instead here, these are just one-shots. So if I want to use bits as one-shots, you can see here, you know, I can just use these as I need to. So
Okay.
anytime you create these, of course, you have to download them into the processor. So these system bits, all these are just names. I made cycle start permissive. I just made names for everything and made bools. So where I used those was here, right? So they have these hard addresses, but it gives you a nice name. It says HMI. I used an HMI block and I called this auto push button, right? And system block, DB1 is system block, and there's my auto mode and manual mode.
Okay.
Right, and then I put comments in there and all this kind of stuff. Then in here, in the blocks, you can also create variable tables. So what I did is created a variable table for the system. And if I monitor it, I can see all the different things happening.
Oh,
right, like I've got a stack light here. So what this stack light means, right? If I go in here and I say, I'm not in auto cycle, right? If I monitor this, you'll see that I'm not in auto cycle, right? So that's off. And the way I go into auto cycle is if I'm in auto mode, which I just toggle bits, right? This is just latched bits. So I'm in auto mode right now because I pressed the auto push button. If I press the manual push button, and yeah, so I can just modify it to a 1, and you go down here and you can see I'm in manual mode. Right, I toggled it. So I'm pushing a fake push button.
Okay, all right.
Yep. So now for auto push button, I'm going to do the same thing. Push the auto push button. Turn it back off. This simulates a spring return push button. Okay, I'm going to turn this off too because I shouldn't be cycle stopping. All right. So now if I press the auto cycle start push button, which is down here, cycle start push button, as long as I have this cycle start permissive, which is another just imaginary bit, right? I just made it up. Then this will run for 3 seconds. It'll beep a buzzer, something like that. I'll show you what this one looks like. So this is my Allen Bradley. If I stop it, see there's my blinking light.
Yeah.
Okay, as I push the button, beep, beep, and then I go into auto cycle.
Oh, that's your 3 seconds.
That's my 3 seconds. So the idea is that while it's beeping, it's warning people, watch out, you know, the machine's
I'm about to start. Yeah.
That's right. So the way I do that, there's kind of a lot to it. Right? You have to be allowed to cycle start. So for instance, maybe I need to detect that I have air on the machine. I need to detect that, I don't know, something's running, you know, maybe the e-stop's not hit, whatever my cycle start permissive is. So I just latched it here. I left it on. You have the same kind of thing here for this cycle stop push button. Do I want to stop immediately? Not necessarily, right? If, for instance, I had some kind of a pick and place and I'm picking something up and I'm carrying it over here, I may want to wait until I got rid of my part to stop my machine.
Okay.
Right? So in that case, I would have a cycle stop permissive would not be on. So I'm going to modify it to a 0. It's not on. Now I'm in auto cycle. I'm telling it I want to stop. But let's see here. Monitoring's kind of hard in Siemens. There we go. Oh, it says I'm not in auto cycle. Why is that? All right, so let's see. Modify to 0. Did I have a fault? No, I didn't have a fault. So look at this again. Cycle start permissive. Oh, I probably didn't even run it. Yeah, beep.
Okay, all right, it's not running.
There we go. Yep. Okay, turn that off. Now I'm in auto cycle. Okay.
Okay.
And now I'm going to turn this on, which is going to say, I want to stop this cycle. Okay. Notice it does not stop.
Yeah.
And now I modify it to 0. It remembers that it's been asked to stop, but it doesn't stop yet. Right? So I'm running, I'm moving, I'm doing my thing, and then all of a sudden I stop doing my thing, and then it says, okay, you're ready to stop.
Oh, there it goes.
Now I stop my auto cycle. So I would be blinking. Okay, so that's the way all that works. So that's what FC1 is doing. And what I also did here is I made like starved and blocked and different things in here. And I'm going to go ahead and we'll turn this one on. I'm going to show you what I did with that. What I did here is I made an hour accumulator in a function block. And this was the one I was showing you before. This is the same thing that we were doing before. I take an input called a device, and I have a clock pulse. The clock pulse is that pulsing bit that you saw before. So let's see, where is it? That clock. So
that accumulator type.
Yes, it's not really. Yes, this will accumulate time. And we'll close that. So Siemens is pretty, you can see how confusing it is because there's so many different things open.
There's so many.
Right. You get used to it after a while, but these are the clock bits. These are the things that I configured in hardware, and they're just constantly pulsing. So this one is a 1 second pulse. Right. You can see it pulsing there, and that's about once per second. Okay. So what I do here is in these function blocks, that pulse is actually coming in. Let's see if we can find it. Oh, wrong block. FC1, it's in OB1. So what those FBs are these. So here's one, test time accumulator. You see it pulsing? So this says that I've been accumulating time for 1 hour, 41 minutes, 23 seconds. Oh, and there's my wife. You still there? All right. I'm going to end my meeting.